Alright, the goal in this video is to figure out how to approximate area under a curve using a method called rectangular right-handed approximation method. I just call it RRAM for right hand. And what we're going to do is we're going to do an example together that we've also done in class. Let's imagine you have the graph of, how about y equals x squared, a parabola. And that typical graph looks like this. So here's y equals x squared. And for some reason, we don't really have a story or a reason why yet, but for some reason we want to know the area, and we've been using the example of 1 to 4. So on the graph, here's 4, and here's 1. We want to find the area in between there. If we were to shade it in, so all of this. And it's not like you're going to be able to pull out an old formula you've memorized like length times width to find the area of such a weird looking shape. If you were to redraw this shaded region, it's a shape that looks like this. I have not memorized a formula to find the area of that type of shape. It's a weird shape, but we have methods of doing it. We have an approximation method called right-handed approximation. What I'm going to do is I'm going to zoom in on this graph and make it a whole lot bigger down below. So I'll scoot this up. I'm going to redraw the graph, but I'm only going to focus now on the important section of the graph, the shaded region. So from 1 to 4. So I'm just going to draw the first quadrant. Here's y equals x squared. I've blown it up and kind of made it bigger so it looks elongated, but we're going to say here's 1, how about here's 2, here's 3, and here's 4. And what I'm going to do is I'm going to split this little region up from 1 to 4 into little rectangles using something called RRAM. R stands for right. So I'm going to start on the right side. If I'm going from 1 to 4, 4 is on the right side. So I'm going to start on 4 up here. I'm going to go up with a straight line and make a point on the curve. Then I'll work my way the other direction. So I'll go to 3 and draw a straight line and put a point on the curve. I'll go to 2, draw a straight line and put a point on the curve. And then what I'm going to do with all these lines is I'm going to build these little rectangles. So go back to 4 where we started and drew our first point right here. I'm going to go to 4 and then draw this straight line over and down that builds a rectangle, and that's going to estimate this area. And then I'm going to go to 3 and draw a line that goes straight across and down, and that's going to estimate this area. And then I'm going to go to 2, draw a line straight across and down, and that's going to estimate this area. So I got 3 different rectangles. You can tell right away that this area that I'm going to be approximating is an overestimation. Just by looking at my rectangles, I'm overestimating because I got a little space above the curve. But that's okay. It's really, really small. If you were to zoom out and actually look at this, it's not a big overestimation. So to figure out our answer, area is going to equal the length times the width of each of these rectangles, these 3 rectangles. So let's look at the length of the first rectangle. It goes from 1 to 2. Well, that's a distance of 1 from 1 to 2. And if I looked at how tall, what's the height of this rectangle from here to here? Well, the height depends on the curve. We started at 2 and went up. So this curve is x squared, and we have 2 here, so 2 squared is 4. So the first rectangle has a height of 4. Plus the next rectangle in the middle here goes from 2 to 3, so that's a width of 1, and its height depends on the point at 3 on the curve. So 3 squared is what's going to go there, or 9. And then the third rectangle, the biggest rectangle on the end here, has another width from 3 to 4 of 1. And then the curve depends on the number 4. 4, if you put it into x squared, is 4 squared. So we have a length times width, length times width, length times width for the 3 different rectangles. So we have 4 plus 9 plus 16. And if we were to add up 4 plus 9 plus 16, we're going to get 29. And area equals 29. And that's our overestimated area. Obviously the area is a little smaller because of this extra space that we have above the curve, but it's got to be somewhat close to 29. And that's how you do a right-handed rectangular approximation. If you wanted to get an even better answer, you would try and fit more rectangles into this space. You would try and chop it up even smaller, like into 6 rectangles or 10 rectangles or 100 rectangles. 100 rectangles would be a ton of work, but your answer gets better as you start to use more rectangles. The more rectangles, the better your answer. So that's pretty important to remember.